Hello friends, welcome back to my channel. So how do you solve this integral? I am going to solve this integral using the King's property, which is very famous in my videos. So the integral from a to b of f of x dx is the same as the integral from a to b of f of a plus b minus x dx. So here in our integral, the a here is actually, that is -1 and b is +1. So a plus b is going to be 0, and then a plus b minus x is going to be -x. So in place of this, our integral, I'm going to just plug in -x. So this is the original integral, and the integral that I'm going to transform using the King's property will be the integral from -1 to 1 of just plugging in -x in place of x in our integral, cosine of -x over 2 plus 1/2 divided by the square root of 4 minus -x squared dx. So I is going to be the integral from -1 to 1 of -x to the third cosine of x over 2. Cosine is an even function, so the cosine of a negative angle is the cosine of a positive angle divided by the square root of 4 minus x squared dx. So this is the integral transformed by the King's property, and this is the original integral. So what I'm going to do next is to sum the integrals. So the integral, the original integral, plus the integral transformed by the King's property, which is equal to the integral from -1 to 1 of x to the third cosine of x over 2 plus 1/2 divided by the square root of 4 minus x squared dx, plus the integral transformed by the King's property, which is this one, which is the integral from -1 to 1 of -x to the third cosine of x over 2 plus 1/2 divided by the square root of 4 minus x squared dx. Nice. So here the left hand side really combines to 2i is equals to, I can put these two integrals into one integral because they have the same denominator. So the integral from -1 to 1 of x to the third cosine of x over 2 plus 1/2 minus x squared, x to the third power cosine of x over 2 plus 1/2 divided by a common denominator, which is square root of 4 minus x squared, all this dx. And there are going to be some cancellations here. So 2i from the left hand side is equal to the integral from -1 to 1 of these guys will cancel out beautifully. Then you have half plus half at the top divided by the square root of 4 minus x squared dx. Half plus half is 1, and that is going to be the integral from -1 to 1 of 1 all over the square root of 4 minus x squared dx. And this is really something familiar. If we can compare this to the sine inverse integral, if we have the integral of 1 all over the square root of a squared minus x squared dx, this is the same as the sine inverse of x over a plus the constant of integration. So this one looks like the sine integral, but I'm going to rewrite it as, so we have 2i is going to be the integral from -1 to 1 of 1 all over the square root of 2 squared minus x squared, because 4 can be written as 2 squared. So that is going to be what the sine inverse of x over a here is 2. Now we are integrating that from -1 to 1. Those are our limits of integration. So now here 2i is going to be, you just plug in your limits. That is going to be the sine inverse of 1 over 2 minus the sine inverse of -1 over 2. Sine inverse is an odd function. So the sine inverse of a negative number like this is going to be the negative of the sine inverse of x. So this is the sine inverse of half minus negative sine inverse of half, and that is going to be 2 times the sine inverse of half, like this. So you can divide both sides by 2, and you have I is just equal to the sine inverse of 1/2. So sine of pi over 6 will give you 1/2. In that case, sine inverse of 1/2 will give you pi over 6. So therefore, I is going to be pi over 6. That's the sine inverse of 1/2. Pi over 6, that's 30. So if we integrate from -1 to 1 of x to the third, cosine of the angle x over 2 plus 1/2 divided by the square root of 4 minus x squared dx. This one evaluates nicely to pi over 6 by courtesy of the King's property. So this is how I can really solve this integral. If you find this helpful, please subscribe to my channel for more engaging tutorials. I thank you so much for watching this video, and I will definitely see you in the next one. Bye bye.